Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called The Smallest Chaotic Killer by Bellamy, or Bellamis. I think it's Bellamy, but I'm not sure. Anyways, here are the rules. Killer cages, where digits do not repeat in cages and sum to the digit in the top left corner. So remember, you cannot have repeats here. So as an example, this cage, these four digits must add up to 13. And you could have something like, I don't know, 1, 2, 4, and 7. Because these four digits add up to 13. Actually, they don't. You would have to have 1, 2, 3, and 7 if that's the case. Or I was going for 1, 2, 4, and 6, I think. That would not work. 1, 2, 4, and 7 would not work because that adds up to 14, which is not allowed. But you could have 1, 2, 4, 6, which would add up to 13, which would make this cage work. However, you could not have something along the lines of, say, what do we do? 1, 2, 8, and 2. Even though if it's possible that these digits would not be in the same box. You can't have essentially or same region, actually, I should say, because it's not necessarily a box. You cannot have duplicates in the same cage. Anyways, that's the rule set for killer cages. We also have chaos construction, where we divide the grid into regions, each consisting of 9 orthogonally connected cells. Each row, column, and region contain the digits 1 through 9 once each. So as an example, something like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, this is valid as a region, right? Because it has 9 digits, 9 cells, and it is orthogonally connected to itself. If, say, we move this over here, this is no longer a valid region as a whole, because this is not connected to the rest of the cells in this region by an edge. Nor this doesn't work either, right? Because these two digits are not connected to the rest of the digits in the rest of the cells in its region by an edge. So everything in a region has to be orthogonally connected to each other. And this is typical chaos construction rules. And finally, we have the smallest digit in each cage counts the number of different regions that enter that cage. Ah, okay, that's interesting. Huh. So the smallest digit in each cage. So if this were to, let's use a better example right now. Say, okay, there aren't that many good examples here. Say if this was a 2 and an 8, you know the smallest digit, 2, basically counts the number of different regions that enter that cage. So there would have to be 2 different regions that enter this cage. So one of these would have to be one region, and this would have to be a different region. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. And this is actually probably a very good introduction to chaos construction rules, because usually chaos construction rules can be very convoluted and difficult to understand. But this one seems actually fairly approachable, I guess, for a chaos construction rule set. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first things first, I see a three cell cage adding up to 8. That means it requires a 1 in there because it can only be 125 or 134 because you have to have unique digits again. So therefore, this is the same region no matter what because we only have one region because again, the smallest digit in each cage counts the number of different regions in that enter that cage. So this has to be 125 or 134. And we know there's a 1 here. 13 cage. There's a 13 cage here with there's 4 cells in this 13 sum cage. What is the minimum digit required? Can we have it without a 1 is the question. And I think the answer is no. If you remove a 1 from this cage, you have 4 digits adding up to 4 unique digits trying to add up to what is the minimum? 2, 3, 4, and 5. 2 and 5 add up to 7 times 2, because it's 3 and 4, adds up to 14, which is too big. So this cage also must have 1 as a minimum. So this is a minimum of 1 and is the same cage. So it has to be 1 through 7, but it must contain a 1. These 2 cell cages here must have either a 1 or 2 in them, right? Because you can have at most 2 different regions in these 2 cell cages. So either this is 1 or 9, or this is 1 or 9. So whatever digit is the minimum here, the other one has to be the other set, right? So this is a 1, 2, 8, 9 pair, right? But if this were 1 and 9, this could not be 1 or 9, 1 and 9, because one of these 2 digits would have to be not a 1 or 9, and that's not allowed. This is also one of 1 or 2. So since this is 1 of 1 or 2, and this is 1 of 1 or 2, this cannot be 1 or 2. This has to be then an 8, 9. The rest of the column cannot contain 1 or 2, right? Because one of these is 1 or 2, one of these is 1 or 2. Therefore, this is 1 or 2 here. Let's see. In the 19 cell, actually, no, in the 20 cells, in the 20 sum cages, which are 3 digits, the minimum you can have is 3, 8, and 9. And there's only 3 spaces, so therefore this must specifically be 3, 8, and 9, because there cannot be 4 regions entering this cage. So this has to be 3, 8, 9. This, and we have 2 digits adding up to 11. This has to be 2 and 9, because you cannot have 1 as with a digit adding up to 11. And these specifically then must have 2 digits adding up to 11. And these have to be separate regions. So where does this region go? We're going to make this light. This region has to go down here because these 2 are in different regions. This one doesn't have to be. So this one is either part. We don't know where these 2 regions are. But this one must go down here because these 2 are in a different region. So it must go down here. This is a separate region. So this is green. So this has to go this way. Which means this cell has to go here. This cell is also, so since this cell has to go here, we're going to make this a pink, I guess. Because this cell, where does this cell go? It has to be part of this region here. Because otherwise, it's not going to work. So again, these are, I'm going to draw the borders. Actually, let's draw the borders around the entire grid. So that we can mark that. We know these are separate regions. This has to get out some way. This has to get out some way. We know this is a separate region. So, and this cannot be 9 because of the 9 to 9 pair in the column. This is a separate region. This region, if this were not part of this medium gray region, where can it go? It only has 3 cells in the region if that's the case. So that can't be part of the region. Therefore, this must go down. This must go this way then, because that's the only way it can get out, and we need 9 cells in each region. This could be light or medium. We don't know which. This is part of a separate region. This is part of a separate region. This is part of a separate region. This must be green then, because it has to go somewhere. Hmm. No. Actually, never mind. Let's see, what else do we have? This cage can either be 2, starts with 2 or 3. And it cannot be 2, because if this were 2, it would have to be 2, 8, and 9, and that would eliminate all possibilities for that cell. So this specifically has to be 3, 7, and 9. And each of these are in a separate region, because 3 is the lowest digit, and that's the number of cages, or number of regions that enter that cage. This can't be 9 anymore, so this must be 2, which makes that a 9. This region must go either this way or this way. We're not sure which. This region is either 2, 7, 2, 8, 9 or 3, 7, 9. Right? Because again, there's only 3 regions maximum possible to enter this cage. And so it's at least, sorry, the least digit, the smallest digit has to be at most a 3. Either way, 9 has to be here. So this can't be 9, but one of these 2 is a 9. Therefore, this cannot be any 2, 3. But it could be, okay, so it could be 1, 1, 3, 1, 2, 8 works. 1, 3, 7 works. 1, 4, 6 works. 2, 3, 6 does not, because that eliminates all possibilities for this cage here. But it could be 2, 4, 5. And we're not sure, though. Also, one of these is a 9. One of these, obviously, this is a 3, 7, 9 triplet. What is the rest of row 3? It has to be 1, 4, 5, 6, and 8. Okay, so these are all possible. The rest of column 7 must be 3 through 9, because it cannot contain a 1 or 2. This can't be 9, though. This is 1 or 2. We have... This is at least 1, 2, 3, 4, 5. It could be 6, 7, 8. That's possible to be part. Oh. The problem with, okay, so this cannot be part of this region here, because this is either 1, 2, 5 or 1, 3, 4 here, which eliminates all possibilities for this cell. So this actually, well, it could be part, 1 cell could be part of it, but 2 cells cannot. Hmm. Um, this is at minimum. So how many digits can be here? Obviously, you can have one as a minimum. Two works also, I think. 2, 3, 5, 9 works as a four set digit. 3, I think, also works. 3, 4, 5, 7 works as a set. But 4 does not work as a minimum. So this is either 1, 2, or 3 as the minimum digit here. Oh, this cannot contain a 9 here. That's interesting. What's the maximum value for 4 digits without a 9? You could have 5, 6, 7, 8, which is 26. Aha. So 9 cannot be here because this is a 2-9 pair. This is, one of these is a 9 because this has to be 3, 8, 9. Therefore, 9 cannot be in any of these digits. Well, to have 4 unique digits adding up to 25 without a 9, it has to be 4, 6, 7, and 8. 6, 7, and 8 adds up to 21, with 4 is 25. If you try to decrease the 6, you would get 5, 5, 7, 8, but you can't have repeats in cages. And if you try to increase the 4, if you decrease the 7 or 8, it still has a duplicate. So that's why this is specifically 4, 6, 7, 8, which means these are all separate regions. That's pretty crazy. Okay, so this is a separate region from this, which is a separate region from that. This then has to go up here. But we don't. Okay, so then I think it has to be part of green, right? This region, where can it go? So it has to be a separate region from this. It has to be a separate region from this. And if we try, I guess it could go out, potentially. But this, okay, so this one has to go that way. This one has to go that way. This one could go out here. We're not sure. So we don't know if this is the same region as this green. We do know this is a separate region here, but it could be part of the yellow. That's fine. Okay, so we know 8 is in one of these cells in this cage. We know 8 is in one of these cells in this cage, so therefore the rest of columns 1 and 2 cannot contain an 8. So this cannot be 8. That's all we know from that. This is at minimum 1 or 2. So if this, I guess it could be red going here that way. This has to be separate from this. So this one continues to here. So we know this is a region block because this one has to go out this way also. Technically could have something like that. Or it's just part of this region. So this is part of this region. Okay, hold up. If this is just part of this one region, so you have just one here, where does this go? This has to go out here, and it could connect to the light, but then this region here is only 6 at most. So this cannot be one region here, because that would block this area to have to go out this way, or this way. And that would block this region to be 6 cells, which is not allowed. So this must have 2 different regions in it then, which makes this 236 or 245. Either way, there is a 2. So one of these has to be, so this cannot cut off this way. This region, whatever this region is has to go either there or it's part of green going out here. Okay, so if this is part of this region here, it cannot go here because then that blocks this, and then this would have to have a minimum digit, smallest digit of being 3, which is not possible. So this has to go out this way. It cannot be part of this region because that blocks up this from going anywhere. So then this part has to be part of green. It has to be part of green, and it must go out this way because it cannot be part of this region. So this is 1, 2, 3, 4, 5, 6, 7, 8. This we don't know what the region that has to be part of. This then has to go this way. So these are blocked. These are blocked. This pink must go. This has to be a separate region, so this must be pink. This light has to continue going that way. So that's 1, 2, 3, 4, 5, 6, which forces the pink to go here. So this is pink. 1, 2, 3, 4, 5. This could be 9 here. This is a separate region, but can it be part of light? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. So this is its own separate region. So we're going to make one of these red. Actually, one of them has to be, almost certainly has to be yellow. And if this cannot be yellow, this cannot be yellow. Yeah, if we try to make this go around, so say we had this, right? And this goes this way. The problem is this region always will have to go here. So if this is not part of yellow, where can this go? If it tries to go here, and then here, right? If it's not part of yellow, say this was its own region, this goes this way, but then it has to go this way, which means this one, which has to be a separate region than green, would be only 2 in length. So this cannot be part of, this has to be part of yellow. So this is 1, 2, 3, 4, 5, 6, 7. This we're going to label red, and I guess we can make this orange. This could go up. We don't know where. This is, we don't know actually that. This region we don't know. It has to go here though. This is orange, we'll make. One of these has to be orange. It cannot be green. So green is either here or here. We're not sure which. And this could be green or orange here. Orange has to be this one because if this were red and tries to go here, that would block the orange. So this has to be orange, which means we know that that has to be a boundary. This could be green. This could be orange. It cannot be red because that would block off the orange region. It could be light. Cannot be purple because this is 1, 2, 3, 4, 5, 6, 7 at most. So this is green or light. We're not sure. This is yellow or red. It cannot be orange because if it were orange, that would block off the red region. This is obviously red or orange. We're not sure there. Okay. Let's see. What else do we have? This cannot be 2. So 2 cannot be here. So 2 in this green region must be either here or here. We're not sure which. Oh, that's interesting. But if this is green and this would have and this were 2, I don't think that works, right? If this is green here and this is specifically a 2, then this region would have to have only 2 regions in it. I guess it could be 1, 2, 3, 4, 5, 6, 7, 8, 9. It could be light. We know light is in this region. Um, the minimum here is 1, 2, or 3. The smallest digit in this cage is 1, 2, or 3. Um, hmm. Okay. Um, oh. Huh. Where are red and orange have to go? I guess orange could be here. So orange could be here. But actually, where is red going? Red. So this is 1, 2, or 3 regions, right? The problem, okay, so you need gray here. You need light gray because that it has no place to go elsewhere. You also need orange here. So this cannot be 2 as a green because orange needs to get out somehow and red needs to get out somehow, and they're both blocked by this yellow. So this cannot be green in a 2. Even if this were green, how does this orange get out with the red getting out? Because we need 9 digits in this red region and this orange region. It can't. So this cannot be green here. This then has to be green here because we don't have 9 digits otherwise. So one of these is a 2 here. So this is a boundary. This is a boundary. Red has to get out somehow. And so it has to go here. This cannot be 1. This is at minimum 2. So it could be 2 or 3 minimum because it has to have 2 regions at least in it. This could be yellow. No, it can't be. If this is yellow, this forces this to be red, which blocks off the orange. Okay, so this can't be red. This has to be orange here. This is then not yellow. This has to be red. So these are all boundaries. These are all boundaries. This red has to go up here, which means this has to be orange, which means this has to be orange. So this is 1, 2, 3, 4, 5, 6. So this has to be 1, 2, 3, 4, 5, 6, 7. And it could be 8 here, but it needs to go at least one more. And this one has to be orange because it has to continue. 1, 2, 3, 4, 5, 6, 7. This has to be orange because it has to exit out. 1, 2, 3, 4, 5, 6, 7, 8. But this could be the 9th here. Or this could be 9th. We don't know. So this has to go here. This purple, or this pink, has to go this way. 1, 2, 3, 4, 5, 6. And it has to go here. 7. This is a separate border. So this has to be light then. Because this can only be one of these 2 regions. It can't be pink because it's a separate region from here. So this has to be light. So then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 lights, which means this cannot be light here. This has to be a medium gray. So this is 1, 2, 3, 4, 5, 6. This cannot go here. This is a separate region. This is a separate region. This is 1, 2, 3, 4, 5, 6, 7, 8. It has to go here, and then it could go somewhere else. This has to go out this way because we only have 1, 2, 3, 4, 5, 6. Therefore, this is a 2 region cage. So this must be 1. This has to be 2 and 3, which eliminates 2 and 3 and the rest of the column. So this can't be 3, this can't be 2, 8. So this is a 1, 9 pair, which makes this not 9. This has to be 8 and 2. So this cannot be 2 here. Red has to go here. So these are all regions. This is only one region in this cage. If we tried to make this yellow, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. But then this cell would not be in a region, which is not allowed because every cell in the grid must be part of a region. So this has to be its own separate region. We're going to make that blue. This can then be yellow or blue. That's 1, 2, 3, 4, 5, 6, 7, 8 at most. So this must be 9. And this must be a separate region. It's like, actually, it probably has to be blue. Well, it doesn't have to be blue. This could be blue or a new region, which will make dark, essentially. So this is a border too. 8 has to be here, so this cannot be 8 here, and 8 cannot be here. This can't be 2. 8 cannot be any of these digits, and 9 cannot be any of these digits. Therefore, this must be a 7, which means these can't be 7. These can't be 7. One of these, so these 3 digits, one of them is a 2 or a 3, because it's either 1, 2, 5 or 1, 3, 4. We have a 2 or a 3 here, which means the rest of the region cannot contain a 2 or 3, because we have 2 cells in the region which require 2 or 3. So this cannot be 2 or 3. This must be 8 or 9, which means this, one of these 2 digits is a 3, which eliminates 3 from the rest of the row. This can't be 3. This must be a 2, which makes this a 3, which means this must be a 1, 2, 5 triplet instead of 1, 3, and 4. But this can't be 2 anymore. This is 2. This has to be part of a separate region. We have 1, 2, 3, 4, 5, 6, 7, 8. We need a 9th digit. It has to be here. And this is part of a separate region, which we're going to label black, because that's 1, 2, 3, 4, 5, 6, 7, 8, 9. This region can't reach it. None of this region's done. Yeah, so we have that. So this must be a 1 or a 5, because the only remaining digit in this region, which is not on row 1, is this cell. So therefore, this must match it. This is a region border. This is a region border. This dark region has to go down here. So this is either 1 with something, well, we don't know. This orange must go out here. This red must go out here. Why? Because 1, 2, 3, 4, 5, 6, 7. Therefore, this is 8. 1, 2, 3, 4, 5, 6, 7, 8. This could go up here, but this red still has to continue out because it can't go down. Therefore, this is 1, 2, 3, 4, 5, 6, 7, 8. We need a 9th digit in this region, or 9th cell in this region, so this must be... oops, I already put the boundary there, even though that was not guaranteed. But we now know that that has to be the case. So this is 1, 2, and 3. This red is fully complete. So, where is the blue getting out of here? Can this ever be dark? No, because the problem is, if it goes dark here, this is only a 6-cell region. So this can't be dark. This has to be blue. We also know, yeah, this is 2 separate regions. So this blue region has to essentially go here. And that's done. So that's 9 cells in that region, which means this cannot be 2. This could be 1, 2, 3, 4, 5, 6, 7, 8. 9 reaches here. This is 1, 2, 3, 4, 5, 6, 7, 8. 9 reaches here. So no other region can reach here except for dark. Therefore, this must be 2, 8, and 9. Which means this can't be 9, this can't be 2. 2 cannot be included here, so this must be 1 as a region. Well, we already knew that too. So these are all dark. And it cannot be 1, 2, 8, but it could be 1, 3, 7, but 3 and 7 can't be here. So it has to be 1, 4, 6. So this must be 1, which makes that a 1. This can't be 1 anymore. This is 4 and 6. The rest of these digits are 3, 5, and 7. This can't be 9 because of the 1, 9 pair in the region. Therefore, that makes this an 8, which makes that a 2, which makes that a 9. This is 4 and 6. 3, 5, and 7, which makes this 4 and 6 here, because that's what's needed in the that's what's remaining in this region. This is 1, 2, 3, 4, 5, 6, 7, 8. We know one of these two is orange, and one of these two is pink. So the rest of this could also be dark, but we know these two are dark. So this cannot contain 1, 4, 6, because we already have a 1, 4, 6 in this region. So it's 5 or 8 here. So you can't have a 4, 6 in the rest of this region. This can't be 1 because of this 1. Eight is in this region. We need a 2 somewhere in this region. Here. So 2 has to be one of those 4, which means 2 cannot be here. Because 2 can't be here, 2 can't be here. Where's the 2 in row 9? It has to be one of these 4. This can't be 2, because one of these has to be 2. This has to have a 2 at minimum. So the 2 has to be here, which eliminates 2 from being that cell. Because one of these has to be 2, because this can't be 2. Therefore, this must be 2 here. And we know there's a 2 minimum here. What could it be? It could be 2, 3, 5, and 8. Okay, so one of these 3 2s is in orange. So therefore, this cannot be 2 here. Whereas the 2 in this cage, which would require, because that has to be the smallest digit, which counts the number of different regions, this must be a 2. Okay. Again, this could be 2, 3, 5, 9, but there's no 9 possible in this. So it could be 2, 3, 6, 8. What about 2, 4? Oh, where is the 9 in this orange region? Well, can't be any of these or this. It can't be any of these, so it has to be here. So this is 9. This 9 sees all the red cells, except for these 3, and these can't be 9 either. So where's the 9 in this red region? It has to be here. This means this 9 means this can't be 9, so this is 3, which makes that a 9. None of these can be 3. This 9 means none of these can be 9, none of these can be 9, none of these can be 9 in the yellow region. Where is the 9 in the yellow region? It has to be here. So this is 9, which means this can't be 9. This is 1, which makes that a 9. This can no longer be a 1. This is either 3, 6, or 4, 5 here. This cannot be 1. Where is the 1 in row 4? It must be one of these 5 cells, which means this cannot be a 1. Oh, 1 also can't be here. Where is the 1 in column 1? Or column, yeah, 1. It has to be one of those 4 cells, which means this cannot be a 1. Where is the 1 in column 2? It must be this cell. So this is 1. None of these can be 1. We cannot have a 1 here, cannot have a 1 here, cannot have 1s here. Where's the 1 in column 3? It has to be this cell. So that's 1. Um, uh, where is the 1 in orange? It cannot be one of these 3 cells because remember, this has to be a minimum of 2 because the smallest digit in that cage counts the number of regions, and we have 2 regions here. So none of these can be 1. This can't be 1. Therefore, this must be the 1, and this must be orange. So it cannot be dark, which means this can't be orange. This is the final digit. This cannot contain a 9 again. We have all the 1s, I think? No, not completely. This can't be 1 in the red region, neither can these. So one of these 2 is a 1. We're not sure which. Again, you could have 2, 3, 6, 8, adding up to 19 for this cage. This cannot be 4 or 6 because of the 4-6 pair in the region. So therefore, this must be 5, which means this can't be 5, this can't be 5. This can't be 5 now because of the 5 in the region, so this must be an 8, which means this can't be 8. This must be either 3 or 7, because those are the only digits remaining in the dark region. This cage, again, okay, so let's actually get through the whole way with this cage. It could be 2, 3, 5, 2, 3, 6, 8, adding up to 19. 2, 4 adds up to 6. Oh, you can't have a 9 in it. So 2, 3, 6, 8. I think 2, 4, 5, 8. 2, 4, 6, 7. Actually, we know we need an 8 here, right? Because 8 cannot be anywhere else in the orange region. So this is 2 and 8. That means the other 2 digits must add up to 9. Interesting. Okay. So cannot be 2, 8, 2, 7, right? Because we have 2 and 8 here. That requires this to be 10. And if we have 9, we already have a 2, so that limits 2 and 7. So 7 can never be in any of this cage. Well, 7 can't be here either, and 7 can't be here. Where is the 7 in the orange region? It has to be here. So this is 7, which means these cannot be 7 here. This, if this is 3 and 6, this is 4. If this is 4 and 5, this is 6. So 4 and 6 cannot be in this region. It must be 3 or 5 here. So if it's 2, 8, and this is 3, this can't be 3 here. This would have to be 3 and 6, or 5 and 4. So this is a 4 or 6. Let's see. What? So this is 4, 6. Actually, what are we missing from this light region? We're missing a 5. Because none of these could be 5. This can't be 5. This can't be 5. So this must be a 5 here. We have a 9. We're missing either a 3 or 7. Because, so if this were 7, that would mean there's no 7 here. Well, but this can't be 7. So this can't be 7 here. This has to be a 3. Which means the rest of this row cannot be contained a 3. So it's specifically 4, 6, 7, 8. Which has a 4, 6, 7, 8 quadruple in this region, in the light region, which means you cannot have 4, 6, 7, 8 in the rest of the region. Therefore, this must be a 3. So this is a 3, which means this can't be 3. All of these digits must see 3, 4, 5, 6, 8, and 1. It sees every digit, every cell in the orange region except for 7 or 9. So therefore, this can only be 7 or 9, but it can't be 9. So this must be then a 7. So where is the 3 in this green region? Can't be any of these cells because of that 3, so it must be here. So this is a 3. This can't be 8. There's the 4. We have a 4, 6, 4, 6 pair in this 25 cage, which eliminates 4 and 6 in the rest of the cage. Therefore, this is an 8. This can't be 1 here. This can't be 1 here because of these ones. So one of these two is a 1. The remaining digits here have to be 1, 4, 5, and 6. So and these can't be 1. So the rest, so this 1, 4, 5, 6 quadruple eliminates 1, 4, 5, and 6 in the rest of the column. Therefore, that leaves this as a 7. We have a 4, 6, 4, 6 pair in row 9, which eliminates 4 and 6 in the rest of the row. This cannot be 4 or 6. This then has to be 2, 3, 5, or 7. This is 2, 3, 5, or 7. If this was 1, 2, 3, 7, the problem is that would leave these two as 3 and that would leave these two as 5 and 5, which would have a duplicate in the same row and the same region, which is not allowed. Therefore, this cannot be 7 here, because we tried to have 1, 2, 3, 7 be this cage, and that eliminates too many digits in these two cages. Therefore, 7 in the yellow region must be one of these two cells, which means this cannot be a 7. Where is the 8 in this red region? Cannot be here, so it has to be one of these two cells. It can't be here. So therefore, these cannot be 8. Cannot be 8. This can't be 5 anymore, so this is 4, 6. This 4, 6 matches that one. This cannot be 3 here. So 3 cannot be here. This must be 2, 5, 8, and this must make that 4. So this is 5, which means this cannot be 5 here. So this must, because of the 2, 5, 8 triplet. So therefore this must be specifically 2, 3, 6, which means this can't be 6, so that makes that 4, which makes that a 6, which makes that 3, which makes that a 6. This 4 and 5 means this cannot be 4 or 5, so this is 6, which means none of these could be 6. This can no longer be 6 here. This can't be 4 here. This 6 means this can't be 6, so therefore this is 4, which makes that a 6. This cannot be 1, 2, 4, and 6, because there's a 6 already in the region. So therefore, and this can't be 6 here, so this must be 4, which makes that a 6. None of these can be 6. So this region, so what is this cage? I think it has to be 1, 3, 4, and 5. It cannot have 7, because that requires 1, 2, 3, 7, and that would eliminate too many possibilities for these two cells. Cannot be 6, because there's a 6 in the region. That means 5 is the highest possible now, and it can then only be 1, 3, 4, 5. So this is 5, which makes that a 1. This has to be a 4, 3, 4 pair. This cannot be 3 or 5, so it's 2 and 7. This 5 means this can't be 5, so this is 3, which means this can't be 3 here. That's 3 in the corner. We celebrate because we know we're getting close to finishing. This can't be 4 because of that 4, so this must be a 3, which makes that a 4. This 1 and 4 means this can't be 1 or 4, so this is 5, which makes that 4, which makes that a 1. This 5 means this can't be 5, so this is 7, which makes that a 5. This can't be 8, So therefore this must be 8. The remaining digit here is a 3. This can't be 8. This can't be 5. This can't be 4. None of these can be 4, actually. We have a 2, 5, 2, 5 pair in column 4, which eliminates 2 and 5 in the rest of the column. So this can't be 2. This must be 7, which makes that a 2. This 7 means this can't be 7, so this is 6, which makes that a 4, which makes that 6, which makes that a 4. This can't be 6 or 7, so that must be 8, which makes that a 7, because it can't be 6 or 8. This can't be 2 again. The remaining digits in row 6 are 1, 5, and 7. This can't be 1 or 5, so this must be a 7, which makes this a 1, which makes that a 5. This 5 means this can't be 5, so this is 2, which makes that 5. This 5 means this can't be 5, so that's 2, which makes that 8, which makes that 5. Remaining digits in column 3 are 4 and 5. This can't be 5, so this is 4, which makes that a 5. Remaining digits in column 5 is a 6, so this is 6. Remaining digits in column 6 is 6 and 8. This can't be 6, so this must be 8, which makes that a 6. This 8 means this can't be 8, so that's a 9, which makes that an 8. That leaves 9 as the last digit here. And we need... oh, this is a 7 either way, but we don't know which region that has to be. Oh, this can't be pink, because it's the same region here. So this is not pink, which means this is dark. This can't be dark. This has to be the region as it is, and this must be a 7. And that's how you solve it. Yeah, this was actually well, it still wasn't really approachable, I guess, but it was one of the simpler chaos construction puzzles that I've done. Very cool use of the smallest digit within a cage being the number of regions it has. That was very... I liked that rule set. It flowed very well, and it made sense all the way through. So, props to Bellamy, or Bellamus, however you pronounce his name. This was a fun chaos construction, but not overwhelmingly difficult. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.